Welcome back, y'all. Some more algebra. Uh, this would be part 2 of 1.1. Now, there is one thing I did forget in the whole part about graphing. I forgot about talking about graphing with the table and why it'll be useful. So let's look at this. So we have the equations that we have covered before were all what we call linear equations, whether we're just plotting points or are given a linear equation or we're graphing this. We just graphed linear equations. Now, but what if you don't have a linear equation? This is not a linear equation. What makes it not linear, y'all? That little 2 right there. This makes it a quadratic. That means there's going to be some curve to this thing. But doesn't mean you can't graph it, even if you don't have a graphing calculator or anything like that. So we have 2 things on here. We have an x and a y, and of course this 3. Now this still kind of works the same way as a slope-intercept form. This is still our y-intercept per se. So y-intercept. Okay. Now our x in this case is what we call a independent variable. Independent. And the y is our dependent. Okay. Independent. So let's define that. Independent meaning it doesn't rely on anything else. Dependent meaning it does rely on something else. So the value of y is very dependent on what x is. So for example, so our y value and our x value. So if I put in a 0 in here, I end up having 0 minus 3. Okay, 0 minus 3, which ultimately gives me a negative 3. So the value of y is negative 3 when the value of x is 0. And I'm going to kind of move this right here to the side. Oh, no. Let me just go ahead and erase it right again. So when I put a 0 in for x, I get a negative 3 for y because, and I'm going to do the math over here, it was 0 minus 3. 0 squared minus 3. Okay. If I put in a 1 in for x, what happens to y? Well, let's see. You get 1 squared minus 3. 1 squared is 1. Minus 3 is negative 2. Yeah. If I put in a, let's go with a 3. If I put in a 3 right here, I'm having 3 squared minus 3. So 3 squared is 9. Minus 3 is 6. So this is our independent. Our dependent, and this is our independent. Now let's kind of look at some negative numbers. Let's do a negative 1. If I put a negative 1, I got negative 1 squared minus 3. Negative 1 squared is positive 1 minus 3 is negative 2. Let's put it in a negative 3. Negative 3 squared, because a positive 9 minus 3 is a 6. So these have, look at these right here. 1 and negative 1, 3 and negative 3. That's the great thing about these squares right here. It just starts curving. So let's kind of graph these points. So it's 0. So when x is 0, y is what we say, negative 3. 1, 2, 3. That's still a y-intercept right there. Let's change the colors of these. There we go. When x is 1, y is negative 2. When x is negative 1, y is still negative 2. What do we say? 3. When x is 3, 1, 2, 3. Y is 6. 1, 2, 3, 4, 5, 6. When x is negative 3, 1, 2, 3, it is still 6 up here. So let's kind of connect the dots here. Looks something like that. Not the best one, but it curves. It's not a straight line, but it curves. Let's kind of put it in a 2 so we kind of have a better picture. If I put in a 2 for x, I get 2 squared, which is 4, minus 3 is 1. So that should be at 1, 2. Oh, yeah, look at this. This should be at 1. There we go. That's a little bit better. So 1. There we go. That's a little more accurate. So the reason we use a table is something like this. Let's say you don't know how that looks naturally, like unlike a linear equation, we don't know necessarily where these look. We can at least substitute these numbers and kind of start graphing these plots right here, x, y, x, y, x, y, x, y. Even though I wrote it kind of backwards, I should have wrote it the other way. I'm sorry. But the coordinate right here will be, the coordinate for this point is 0, comma, negative 3, 1, comma, negative 2. 3, comma 6, negative 1, comma negative 2, and negative 3, comma 6. And again, if we put a 2, we got a 1. If we put a negative 2, same thing, we get a 1. So 2, comma 1, and negative 2, comma 1. These are our order pair for the first couple ones, right? We could keep going on, but we're not going to. That's where we put the RSB in. It keeps going on that way. All right, so now to get into the new part right here, start with the distance formula. So the distance formula is exactly that. It helps us find the distance between 2 points. So we got, again, the equation square root of, again, this all ultimately equals the distance. X2 minus x1, y2 minus y1. So this x2 and y2s and y1s, x1s, those are the set of order pair. Which is the x1? Well, the first set will be our x1, y1. Doesn't matter which one you call the ones or which one they call twos. The second set will be our x2, y2. Okay? Now, the great thing of the distance formula is all about just plugging it in. That's all you're doing, just plugging things in. So let's do that. We got square root, don't forget your square root of x2, which we're calling -4, minus, now understand these signs are there because they're going to just come along. So minus, so x2 minus +2, quantity square, plus y2, which is -3, minus 4, quantity square. Again, order operation says we work from the inside, so -4 and -2 gives us a -6. Quantity square plus -3 minus -4 is -7 quantity square. And don't forget your square root, y'all. Don't forget your square root. That is still there. We square -6, so -6 and -6 is a +36, and then -7 square is a +49 quantity square. Now we add them up. We get radical 85. Now, you can leave this as radical 85, and I would, if you want to get it, if it asks you for an approximation, you can go ahead and put it in your calculator, and it should round off to be roughly 9.22. 9.22. Okay, and the only reason we'll might use that is strictly just because either one, they ask us to round to 2 or 3 decimals. I think in your homework actually asks you to round to 3 decimals. So this was 92195, so that rounds off even more to 9.22. Actually, so yeah, 9.22. Because we look at the third decimal, and then we look at the one after that. So the 5 tells us to round the 9 up, or it rounds off to 10. So you add a 1 over here, so 9.22. All right, so that's the distance formula. Another thing that can help us out sometimes, which we'll put it all together at the very end, is the midpoint formula. The midpoint formula still uses 2 points. You still have an x1, y1, x2, y2. But this time we're looking for a third point that's right in the middle of this whole thing right here. So just like before, it's all about plugging it in and working it out. So x1, y1, x2, y2. So let's plug those in. So we put -4. We'll do it over here. -4, comma, plus 2 over 2, comma, and then we do -2 plus 5 over 2. So -4 and 2 gives us a -2 over 2, and then -2 and 5 gives us a 3 over 2. 3 over 2. Let's go ahead and reduce this. When we reduce this right here, we just get a -1. This will leave it as a fraction. You can put 1.5, but I'd rather just leave it as a fraction unless we're plotting it. And there you go. This will now be considered our x, m, y, m, or x midpoint, y midpoint. So these, like we said, these are 2 points on the equation. This would be our x1, y1. This would be our x2, y2. We found the midpoint, which we'll just call x, m, y, m. There'll be a couple of problems where you have to work this backwards, but they'll give you this, and you're looking for that right there. Let's try another example here. So you want to pause it and you can try it. You can work that out. All right. So hopefully you did try it. So let's do the same thing again. This is x1, y1, x2, y2. So we'll do -1 over 6 plus -2 over 3 over 2, and then comma. We'll do -3 over 5 plus a 5 over 4. Perfect. Now, With these, let's go ahead and just get a common denominator. So in this case, it's 6. So we'll multiply this by 2, this by 2. Over here, it's 20. So we'll multiply this by 4, this by 4, this by 5, and this by 5. When we do that, we end up having negative 1 over 6 plus 4 over 6 over 2. And then over here, we'll have negative 12 over 20 plus 25 over 20 over 2. Combined like terms, so negative 1 plus 4 is, of course, negative 3 over 2. Oh, not 3 over 2, sorry. 3 over 6 over 2. Here we add those, we end up getting 13 over 20 over 2. Now, we will reduce this here in a bit, but remember, when you have a negative a fraction in a fraction here, we're going to take this and bring it up here next to it. So now this is saying negative 3 over 6 divided by 2. So we're going to write it side by side, divided by 2. Now, because it's divided by 2, it's 2 over 1. Remember, you can divide fractions, so you multiply by reciprocal. Negative 3 over 6 times 1 over 2. Now, like we said, this does reduce. This will reduce by 1. This will reduce by, they're reduced by 3. So you end up getting 1/2 right there. So you got 1/2 times negative 1/2 times negative 1/2 is just a negative 1/4. 1 times 1, 2 times 2. So that's our x coordinate, our x negative 1/4. Let's do that over here. Same thing. We're going to bring this over here. So it'll be 13 over 20 divided by 2. So you can't do this. So it'll be 13 over 20 times 1/2. You multiply 13 times 1, you get 13. 20 times 2 is 40. And this is our final answer. This is our midpoint between these 2 points. And it seemed pretty long, but I broke it down just so you can see exactly where I got everything. Out these steps you can kind of skip because you guys are smart enough to realize, common denominator, just go ahead and bring that over here. All right, our last thing our new part that we're talking about here is the equation of a circle. Now, this is what we call a standard form. Standard form of it, the equation of a circle has what we call a center and a radius. And those are the only thing that should have actual values. Your center, HK, and your radius. Now, in the equation, it'll be r squared, so you'll have a number squared. But they'll more likely go ahead and square it, as we'll see here in a bit. So this is the formula for the equation of a circle. Now, if you're given just this information, so hey, find the equation of a circle that has a radius 5 and a center 3, negative 4. All we're doing, just like the last two, is substituting. This is our h, this is our k, and this is our r. We're going to substitute those points right there. So we'll have x minus 3 quantity square plus y minus, and it's minus a negative 7. So we minus a negative 7 quantity square equals 5 square. Now, in most of these equations, you do not leave this as square. These you will, like the whole equation. But we got to fix it. So let's clean this up. When we clean this up, we got x minus 3 quantity square plus, now it's y plus 7 quantity square equals 25. Now this, a lot prettier right there. So this is what we'll be looking for as you go through and work on equations. Now also though, from looking at the equations, when we're graphing the circle, we can look at the equation and where there's two things we absolutely need. We need a radius, like we said. We need to know what is the radius and what is the center, which will be our h comma k. We need those two things. The two main things we need when graphing a circle. All right, so let's look at this. All right, so this is our h, this is our k. Now remember, the original equation for hk is x minus h, y minus k. And as we saw down here, when you have a negative value, it switches that to positive. So because both of these are negative, then our hk will both be, both of these are positive. That means our hk, our center, will be negative 4, negative 5. Now, this right here is r square. 9 equals r squared. I want just r, so I'll square root both sides. 3 equals r. So our radius is 3. So when graphing these, we start with our center. Negative 4, 1, 2, 3, 4. Negative 5, 1, 2, 3, 4, 5. The best way to go about this is graph 4 main points. your radius up, 1, 2, 3. Now remember, if you don't remember from geometry or even algebra 2, radius is the distance from the center to the circle. Okay, so radius to the left, 1, 2, 3. Radius down, 1, 2, 3. And radius to the right, 1, 2, 3. From there, we can go ahead and then kind of sketch our circle. It doesn't have to be the most perfect circle, but try to do it as circular as positive as possible. There we go. That's somewhat of a circle. I one time in when I was doing geometry, I had kids just do, all right, here's my center, here's my 4 points. There we go. There's my circle. I'm like, come on, man, come on. So try to do the best possible circle you can. So that being said, this is our last example. It's kind of benefit you quite a bit. So we're gonna find the equation. So we want our equation. Remember, the equation looks like this: x minus h. Ooh, my pen's being weird. A squared plus y minus k quantity squared equals r squared. Ultimately, this is what we're looking for eventually. So we're going to find the equation of a circle where 2 points, here's the 2 points, are opposites of each other. Here's the key word, the key part, opposites of each other. If they're complete opposites of each other, what does that mean, you think? If they're complete opposites of each other, that means they are perfectly go across, the distance across from them is perfectly goes through the middle. Well, what is this right here? From geometry, just kind of think about, what is this called when you go across the middle of a circle? This is our diameter. Diameter. Well, the diameter is also equal to radius. Radii for plural. It's 2 radii. Now, what's also in the diameter? What's in the middle? Hey, our center. So when 2 points are complete opposites of each other, perfect opposites across a circle, they go through the center, and the distance between them is the radius. Now, that being said, there's a couple key things that I said. Distance between them. Distance, which is the diameter, and it goes through the center. Well, the center, since this is a radii, what will the center be considered in comparison to both these 2 points? Midpoint. Hey, this is how we tie it all in together, y'all. All right, so we're going to do 2 things. We first got to find this distance so we can ultimately find our radius. And we got to find the midpoint so we can have our center. So we'll start with the distance part, distance. So remember, this is our, I'm going to change this color now, x1, y1, and this is our x2, y2. So that's the distance formula goes. So hopefully you wrote this down or already have it memorized. As the distance goes, we're going to do square root of x2, which we say is -3, minus x1, which is -8, quantity square, plus y2, which is 2, minus y1, which is 7, quantity square. All right, so minus the negative, that means it's -3 plus 8, plus, and then 2 minus 7 is -5. I'm going to simplify that. -3 plus 8 is 5 squared, and this is plus -5 squared. Common mistake that we do is we think that we have a negative square, you get like a negative answer. No, a -5 times a -5 is a positive 25. A 5 times a 5 is a positive 25. Add them up, we get radical 50. Now you can leave it like this, or you can go ahead and simplify it. Either one, you end up getting 5 radical 2. I will leave it in radical form and probably keep this one. And if for this case, let's use this one. All right, so that right there is our distance. That is our, actually, yeah, we'll leave it like that. This right here is our distance, okay? Distance is all the way across. It's also our diameter in this case. So this is our diameter. Meter. What do we need, y'all? We need a radius. Well, the diameter is 2 radii, so we divide this by 2. So radical 50 divided by 2 is just radical 50 over 2. It's okay. Let's leave it like that for now. Okay, so let's put this to the side over here. So radius equals radical 50 over 2. All right, now we need to find the midpoint because the midpoint will give us our center. So let's do that. Remember the midpoint formula, as it's stated, is you add your x's divided by 2, you add your y's divided by 2. So let's do that. Do this in this blue right here. So we're going to add my x's. So I have -8 plus -3 over 2, comma, then I got 7 plus 2 divided by 2. Okay, -8, -3 gives us, y'all, -11 over 2. And then 7 plus 2, 7, 8, 9, 9 over 2. And we can leave it like this, or we can do it in, I guess since we're going to put it in the equation, it actually doesn't matter. So we'll do this, or we can do both. We'll do -5.5 and then comma 4.5. We'll do that as decimals for now, like that. All right, so we have our center now, and we have our radius. Let's plug it in. So we got x minus a -5.5 quantity square plus y plus, plus, no, not plus, minus, it's minus 4.5 quantity square equals our radius, radical 50 over 2 squared. Let's clean this up, y'all. All right, so then we got x plus 5.5 quantity square plus y minus 4.5 quantity square. So we're good on this side. Now, we're going to square this. Now, when you're squaring a fraction, as you remember from first semester, you're going to square the top number and the bottom number individually. Now, when you square a radical, it just gets rid of the radical, so I'm left with just 50. 2 square is 4. Can I divide that? What's the answer, y'all? The answer is yes. 50 divided by 4 gives me 12.5. So my radius would be 12.5. My r square is 12.5. All right, y'all. That's our answer. Since we're doing 0.5s. Now, if we weren't doing 0.5s, if we were doing this in fraction form, in fraction form, it'd still be there. You can still do like this. It'd be x plus 11 over 2 quantity square plus y minus 9 over 2 quantity square equals 50 over 4 reduces by 225 over 2. You can do this. This will also be a proper answer. All right. You'll have a problem like this. I'll tell you right now. You will have a problem similar to this. So don't forget, it can be broken down to two things: distance and midpoint. And knowing that these are opposites of each other. All right, y'all. Hopefully that helps. If you have any questions, feel free to ask. Bye.